I see who my bright ones are. They're signing in. That's right. How do you like this jazzy? This is a jazzy Kahoot. I'm kind of digging it. Yeah. Okay. You haven't signed in. Sign into Kahoot. Now, it's a little tricky. I'll turn down my Kahoot music. Okay. Although I'm sad to turn it down. Where's my volume? All right, you guys are doing it. Oh, Jared, you're going by print. I like it. He's Pythonized. Turn down my, I'm really liking this song from the Kahoot. All right, how are we doing here? Let's see what we have. We've got, all right, we have, this is really, Chapman, how do you like this music? It's pretty good, huh? Yeah.
For a few minutes, yes.
Oh, don't be an old coot.
I love it.
There, I love it. I heard that. I like that. Okay, do we have almost everybody here? Let's see. Yes, since you might have gone by aliases, I don't know.
We've got 16 students.
7, 8, 9, 10. Well, how come I only have 12 on the Kahoot? Come on, can some of you not do it? Because of some, like you're signing into something else? All right, well, we're gonna get rolling. If you can't sign in, you're gonna miss this great opportunity.
944-8078.
Oh, I'm sorry, yeah, okay. Let me get this.
Oh my God, I'm not.
There, 944-8078. So it's probably easiest if you do it with the Kahoot app. Okay, I should turn this down. Okay, sorry, bye music, I like you, but gotta go. So it's probably easier to do it with the app only because after much investigating, you have to look at my screen for the questions, and then you just have to know, after you look at my screen, then you have to switch over to your screen to be able to do the answers. So, all right. So let's have a little fun. Let's start the morning off with a little game. So I'm going to start the game. I'll just put a little tiny music on. I have to have some. There, that's good enough. All right, here we go. Python Kahoot 1. Okay, so almost everybody, some people thought that it might be a method, which is, it's understandable, but it is a function. Excellent. Okay. Whoa, okay, look at this. Ruth and Sabisco, you guys are really fighting for the top. Here's the next question. Okay, so remember, indexes always start with a 0. So the right answer is 1, because 0, 1. Okay, remember that. Next question. Oh, here we go. Who's in the, oh, Sabisco is still in the lead. Okay, Hannah's catching up though. All right, next question. Loop statement.
Tens bom uma de maneira, não.
Cars. So for car, that's the variable in cars. This is the list name, cars. So at least most of you realize that it was not the word in. Excellent. So cars is the name of our list. All right, let's see where we are. Oh, I'm sorry. We didn't get to recognize whoever you were. Sorry, I was too fast. All right. For loop statement for bug and bugs. This time, what word represents the variable? Ah, you guys learn quick. That's right, bug, because the name of the list is bugs. Okay, let's see where we are in our, okay. Oh, Hannah is now in the lead. Sam's coming up. All right, we still have a chance. Here's the next question. I know it's a little messy. You would never code it like this. Excellent. So the good news is, okay, so one person was a little confused and put the capital P, never. Okay, no capital P's, but here we go, print, and then it's a function, so we have just the regular parens. Excellent job. Okay, I think this might be the next one, might be our last question. So who are, oh, Hannah, you're still in the lead there, but Sam's still catching up. Okay, here we go. Oh, William, you're picking up with a streak of 5 correct answers in a row. Excellent. All right, next. I think this might be the last one. Yep. Little math. Okay, so almost everybody got it right here. Remember that we do our mathematic operation of multiplication first, and then we would do our addition. So it would be 3 times 8 is 24, plus 4 is 28, so 14. So let's see what our scoreboard looks like. Make it a little louder. Sabisco, okay, yay. William, you came up, wow, and I bet it's gonna be Sam, whoa, okay. Excellent. All right, wasn't that fun? All right, so that is it. We are done with the Kahoot. All right. So now, wasn't that great fun, the way to start the week? Yep, where are you guys? Where are you hiding from me? My participants. Okay, you're someplace. I gotta find your faces again. You know, you would think I would get good at this by this point, but I don't do such a good job with this part. All right, well, you're somewhere hiding on me. Oh, here you are. Boom. There we go. Okay, why do I only see you, Mr. Chapman? I don't need to see you. All right. All right, did you like the Kahoot game?
People are not running their video.
Okay. Anyhow, oh, did you turn on the video? Are we?
I did, but most people have not.
No, but are we recording this?
Yes, you've got the recording going.
All right, perfect. All right, so this, I think, is a fun way for us to review. So as you know, I am struggling with figuring out how we do that extra thing. So this time we did the discussion board, and the discussion board went okay. But I think what I'm going to have you do, and because I know you guys are so flexible, I think what I want you to do is, when it's your turn, and I'll send you an email, you know, from that list that you signed up for. So if you recall, we signed up for a list somewhere. I don't remember where it is now. We signed up for a list to do to lead the discussion. I think under assignments. I'm not going to take too much time, I promise, because we get further behind by the minute. But remember, we did this present your answers. So, and we have this list. So Sam did it, and now I think this week Timothy and Soraya are doing it. So I'm wondering if, instead of presenting your answers, we can now just, you guys create a Kahoot. All right, so on Thursday, could you guys create a Kahoot, and we'd start the class out with a Thursday? And then the next week, Ruth, you could create a Kahoot for Monday. And then Hannah, you could create one for Thursday. And then the next week, William, you can create one, and then we just won't have one for Thursday. And then for chapter 6, I'll create one. Or if Timothy or Soraya wants to do it for chapter 6, that's great too. But the idea being that we have a Kahoot to kind of review. It's just a good way to energize, get a little energy going, and to have some quick reminders. And it's just simple. You see, I just had 6 questions. You could have 5, just easy. And it would be on the chapter that we're doing. So for example, I will change this a little bit, because now we're on chapter 4. So I would want to do chapter 4. So anyhow, I might make some changes to this, just slightly. Would you guys be okay with that? And I just assign you a day for a Kahoot. How about that?
That sounds good.
Yeah, and it's more fun too. And then you get your points. All you have to do is a Kahoot. And you don't have to monitor the discussion board, and it's a review. So, all right, we're gonna do that. Good participation, I'm really happy. So I'll fix that up, and then I'll send you a note. And so Timothy or Soraya, could one of you or both of you jointly do a Kahoot? Would one of you be willing to do one for Thursday? Any volunteers between the two of you?
Sure.
Okay, Timothy's going to take Thursday. Excellent. So, Soraya, I will assign you probably to week 6. Okay? All right, perfect. Perfect. So what we're going to do today is we're going to finish up chapter 4. And there's a few things with chapter 4 that we'll review. And we'll have a little, in the middle of class, we'll do a little exercise together. And then we're going to go into chapter 5. So within the module, there's a PowerPoint, and I'm going to be bringing it up right now. It's here, and it's that chapter 4 PowerPoint. We've kind of made a little tweak to it, but I'm going to bring it up, and I'm going to be utilizing my Google Colab. Part of this lecture I will do. I thought I had it up. Well, I don't know what happened to it. part of this lecture I'm going to do, and then part of the lecture Mr. Chapman will do. So, and he'll start us with chapter 5. And keep working on the homework. You guys are doing a really good job. I'm confident that by the end we're going to have this homework. It's going to be real smooth. Right now it's still a little messy. People are still a little struggling with some of the ways we have to actually the ways we have to submit it. But I know we're going to get there. I'm confident. But we're moving along nicely, and I see a lot of good Python going on. All right, so we are all the way. We've gone through this indented. Yes, we're all the way to slicing, if I recall. But I'm not going to talk about slicing. I'm going to just talk about starting out with min, max, and sum. So within a list, if you remember a list, and I'll bring up my Google Colab so you can see, within a list, we can, have like numbers, all right? So this is, and it can, within that, we can do some very simple statistics. So within simple descriptive statistics, we call those descriptive statistics. And usually it's like the minimum value, the maximum value, the median value, and that we can sum things. We are going to talk about 3 of these types of statistics, if I could say the word statistic. And one of them one of them is going to be min. So here's just an example of, a list. So we know a list because we have, the list is named ages. This is the name of our list. We always have our list in our square brackets, and we have, a comma between the items. And then what we're going to create here is a variable. So here is our variable, youngest, and we're going to say youngest equals min, that's the word, the Python word, and it's going to have the word, it's going to go to the list ages. Just a minute, I'm just going to close the door for a minute because it's too noisy. I hear all kind of echoing. Okay, so we have this min ages. So if we go to my Google Colab here and just kind of look at this and make this bigger. There we go. So we have our ages here, like we talked about. The list, very simple, youngest, min, ages. We print, and sure enough, it's going to go and it's going to find the minimum age. So here it is for our min. So if we wanted to find the maximum age, instead of that, what we would just use is we create another variable. This is a variable here. So here is the name of our list, ages. Ages is the name of our list. Oldest is the variable that we're creating that's going to equal the max age, and we're going to print oldest. And it's going to find our oldest, and it says, oh, our oldest is 99, and it's printing them. So then the third one we want to talk about is summing them all together. So, okay, so what is this word ages? What does that equal? What does that represent? What is ages?
A list.
It's a list. Thank you. Okay, and what is this word total years? What does that represent?
Variable.
A variable, thank you. And the variable is going to equal sum, which is a Python word, which is going to do some kind of summarizing. It's summarizing the values in the list ages, right? So it's adding those together. So when we print total years, which is the variable here, we get 557. So you can see here, these are just three different types of statistics that we can easily use within Python to be able to get some values. All right, so the next thing we want to talk about is slicing. Okay, so John, are you there to talk about slicing? Okay. Okay. So he apparently is not there right now. So when we think about slicing, we're thinking about looking at a list, and we're looking at a portion of a list. So what do we, if we can look at this particular slide, oh, if I could bring it, keep it. The first thing we want to say is in our list here, we've got, you know, Kai, Abe, Ada, Gus, and Zoe. All right. We have 5 elements within our list.
Dr. Conrad?
Yes. Are you back?
Yes, the repairman just came to check the stones on the patio.
Oh, all right. Well,
everything happens at once, so
yeah.
I can take over now.
Okay, thank you. Start with your slicing a list. You spent a lot of time on
But
it.
yeah, should I
Just start here.
take
Slicing a
the
list.
screen? Start my
Oh,
screen.
I'm sorry. Yes, sorry.
All right, so let me start my screen.
Okay, can you do it?
Yeah, just a sec. Let me just see. This is host disabled attendee
Oh,
screen sharing.
that host can't seem to get it together. Okay, let's see. I know I'm not the best at this. Well, why don't you just go with me, and I'll just be just tell me when to move to next, okay?
Okay, but then I can't copy and paste and
Oh, okay.
do all fancy things.
Okay. Yeah, sometimes I can't find that that little Zoom thing. I don't know what happens to it. No.
All right. Well, while you let me talk about this little.
All right, you talk about it while I figure it out.
Yes. So basically, what we have at the bottom here is a little picture of what a list looks like. And so there's a list. In this case, there's a list of 5 names, and then below each one is the index. Now, the thing to keep in mind is that the index starts with position 0, and it's sort of like time. Time starts the year 0 AD, or what's now called Common Era, CE, starts with the year 0. And really, the first year runs from 0 to 1. Likewise, the first century runs from the year 0 to the year 100. And then you start the second century, which goes from the 100 to the 200. But if you're in the 100s, you're in actually the second century. And it's similar with lists. And in part, it's because these lists are stored in memory. So when you create a list, in this case, you've got a list of 5 names, you reserve 5 portions of memory, and each portion has an index. And what makes this, and this is actually what's called random access memory, RAM, in that if we want to go to, say, the third name, which is Ada, on the list, we don't have to go through them one at a time, sequentially. Go 1, 2, 3, there's Ada. We can simply put in a number, and then that number takes us right there. We don't have to step through them sequentially. We can go randomly simply by referring to the index. And so what happens is the index runs from 1 to 4, and then the 5th position you can see is empty because there's not a 6th name. And if you start going in reverse order, you start at the end, which is 5. And so if you go -1, then the -1 index is the same as the 4th. That's going to be the name Zoe. Now, when we talk about slicing a list, what we do is we want to look at a subsection of this list. So what we want to do is we want to say, create a list. In this case, we'll create a list of the 2nd to the 4th items. And the way we can do, so we've got a list, and this could be like a race, and we want to create some list of the second through fourth people because maybe we're giving them a different type of medal for finishing the race. So we create some variable for the list. And then we go the finishers, that's our list. And we start at index 1 and we end at index 4. So it goes from 1 to 2, 2 to 3, and 3 to 4, and ends there. So with this statement, finishers equals these 5, and the middle finishers goes from 1 to 4, then our index goes from this point to this point, and actually, you're not on my screen, are you?
No. So what I can do is bring up my, I think I fixed whatever the problem
I'm
was.
showing them on my screen, but
Yeah,
I can't
well,
see my screen.
all right. So I'm going to now do what I should have done in the beginning. Oh, some of this is just tricky for me. You would think
You can't give me screen sharing privilege?
I should be able to, but when you're in the middle of, can you? So I think now, I don't know where that screen sharing thing is.
It says I'm still disabled.
Yeah, I know it is. Guys, help me. Where is it? What am I missing here? It should be like right around here.
If you go to participants and you click on his name, you should be able to give him permission in that way.
Okay, so if I go to participants, there we go. And his name there. You are so smart. Make host. Okay. You should be able to do it. Okay, John, you have it.
Okay, and then
Right now we see Kahoot.
all right, let me go to.
Now we see the Harvard Journal of Law.
So you guys can see what I'm reading. All right, here we go. Hopefully you can, all see this now, the PowerPoint slide.
Yep.
So what you couldn't see was my little cursor here. And that's kind of important because what I wanted to show you is, first of all, we create a list of, this could be a race and we've got the top 5 finishers, and we create a list of the top 5 finishers. And so this is what kind of goes into memory. Each time we create a name on this list, we reserve a little piece of memory for the name of that person. And then we have an index which starts with 0, and then it increases each time we add a name. So it then increases from 0 to 1 to 2 to 3 to 4, and then to 5, and it ends at 5 because we haven't entered a 6th person. And there's also the reverse index, which then starts with 5 and works in the opposite. So 5 minus 1 is 4, and so this is the minus first position is the 5th person here. The minus second is going to be the 4th finisher, Gus, and so on down. And I was talking a little bit about RAM, that this is considered random access memory, in that to find out who the 3rd finisher is, we don't have to go count 1, 2, 3. We just enter a number, which in this case would be either 2 or minus 3. So finisher 2 would then be the 3rd person. And we can go straight to that person without having to step through each individual. So now if we want to slice, if we want to take a segment of this list, what we could do is we could define a new list, which I'll call middle 3. And then we start with the list we want to slice, and we start with the first element in the list at position 1, which is right here, and the final position 4, which is here, and we slice from this position here, beginning with 1, and ending here at 4. So this would take this person, and this person, and put them in this middle 3 finishers. So that's what you kind of have to get used to, is this little idea of indexing, where you put the index 1 is actually here. It's not the first. It defines the position of the second person, not the position of the first person. And
Okay,
then it runs up to 4.
let's see
Now-
the code. Let's see the code.
Okay, so if I want, I can sort of just copy this here. Now, unfortunately, this is in PowerPoint, and PowerPoint adds a lot of formatting, so I can't directly put it into Colab because Colab doesn't weed out all this formatting that's in it. I first got to go to a text editor, and like PyCharm or Sublime. And let me just use Sublime here. And so let me start a new one. So I will simply paste it in here in Sublime. And then I could put in a print. I could put in the finishers, or I could print the middle 3. Now, let me just save this. And that's fine. And then if I'm using Sublime, which is here as my text editor, then I can go, what I do is I go to what's called a build to run it. And you can see what it's done here is it's listed the middle 3, Abe, Ada, and Gus, in a new list here.
So I'm just going to make one quick comment. So the takeaway from this is, you see that 1:4, it includes the first one, Abe, but it doesn't include the 4th. So it's 1, 2, and 3. So just remember that 4 is not going to
The
come
second,
with it.
the third, and the 4th, but not the 1st and the 5th.
Okay. All right. Keep going.
So, so this the second, third, 4th, but not the Chi and Zoe are not in that list. Now, what I was saying is what I did was I copied and pasted from PowerPoint to my text editor. I could now take this here, copy the code from my text editor and paste it in Colab, and then it would run in Colab. But let me go on at this point.
Yep.
So that's slicing a segment. In this case, I wanted to pick out the second, third, 4th items. Now, here's certain rules. Now, if I left off the first index at the beginning of the list, and if I leave off the first number it'll start at the very beginning. If I don't have a number for the first index, and if I don't have a number for the last element, it'll run through the rest of the list.
Okay. So let's see that. Let's see that in the code.
So just quickly going back to here. So on this one here, I've got finishers from 1 to 4. So suppose I just had that emptied and then ran it. What will happen? Well, what should happen is it goes from Chi to Gus. So let me run it, and it does, Chi to Gus. If I left off the last one, then what? Well, it begins with the first and runs all the way to the end. So it should be essentially make a copy of the entire list. So let me run it, boom. And you can see I've got the same as the original list here. So I've actually made a copy of the list, which I now call middle 3. But it's the same as the original list. So I could also, print finishers. The original list, and run it, and you can see that both lists are the same. Now, if I wanted to just simply leave off the winner and print everybody else, I could then here put in a 1 here and then build. And if you notice, my list now left out Kai, the winner. So that's kind of how to basically pick the elements that you want to run to slice through on your list. Now, notice also here that the first item I could have started with a negative number, -3. Well, what's -3 on this list here? Well, -3 corresponds to eta. So if I had put a -3 to the end, then it would have started here at this -3 position and printed all the way to the end. So that should print Ada, Gus, and Zoe. So let me go back, to here. So if I started the middle 3 here, and I put a -3 here and to the end, and now let me run it. Boom. You can see it goes Ada, Gus, Zoe, which is Ada, Gus, Zoe. So it started here to the end. So that's another way of slicing if I wanted the last 3 finishers. Suppose there are only 5. If I wanted the last 3 finishers, I could have started with a -3 and gone to the end. Well, actually, like right here. So if I wanted just to print the last 3, I could have done finishers starting at the -3 position, that's right here, to the end. So that's basically how to slice a list. That is, pick out a subset of that list. Now, oops, I'm sorry, I'm going the wrong direction on this.
No, nope, you're not. Keep going.
Oops, boom, boom.
There you are.
Okay. Now, what we can do now is we've talked about looping with this, which is using this for statement where you run through a list. So suppose I wanted to print just the name of the first 3 finishers. So then I might create code like this here. Let me just, I've already got my list. Let me just copy this, go back to my editor. So here's my list of finishers. And then I said, I want to print, here are the first 3 finishers. And then I do this for statement, our loop statement. And I say for finisher in finishers. And then you start here, since it's blank, and you start at position 0, and you end at position 3, print the finishers. So I'm saying, let me start at position 0, end at position 3, which is here, and print. So I'm saying, start here, print it, go here, print it, go here, print it, and end. So if I've entered the code correctly, let me run it. Boom. Here are the first 3 finishers, Kai, Abe, Ada. Kai, Abe, Ada, which is what we wanted it to do.
Okay, so what is one of the first differences you see by printing it as it's a loop? What do you see? Class.
They all print on their own line.
Right, exactly. All right. So now we're printing them as a line. So you can see how we can integrate the loop function into this, into our list function here with slicing. So let's just review, because I like to do this. So what the first word finishers up here in line 1, what is that?
Variable. Variable.
The name of a list.
Name of a list. Okay, we're going to get to the variable in a minute. So the finishers at the first line is the name of the list. Okay, now we come down to the print function. What is the print? Well, I just told you, it's a function, right? So now we have here something that says, here are the first 3 finishers. It's just text, right? So I'm not going to ask you that question. It's just text that's going to print, okay? And then what do we have when you see the 4? What do we know is going to happen here? What was happening here? Is this with this list? It becomes what? It goes through what process? It is a
Loop.
loop. Thank you. Okay, so for finisher. Now, what is finisher?
Variable.
Variable, right. For finisher, it's each of these items. It's the variable of each of these items. For finisher, in finishers, the list, and now we say finishers, and then we have this :3. So what's that going to do? It's going to start at which one?
0.
0, right. And it's going to go all the way through
To the 4.
Up to position 3, yes.
Yeah.
up to position 3. So it's going to, because remember, Kai is 0, Abe is 1, Ada is 2. So it's going to do those 3 indexes up, and then it's going to print each of them in a line.
So it's saying to start here at 0, end here at 3, and print everything in between.
So we will give you more of these to be confused later, but let's continue moving forward. Okay, so now we're in the
So,
next,
let's see.
we're done with that. Go to the next slide. All right, we did the looping, okay. Might be,
And then now here, copying a list. Well, let me just do something a little more sophisticated.
no more sophistication. We're gonna copy a list.
Well, let me just quickly run through this. Suppose I create a null list, okay? And let me call this just simply first. And let me create an empty list like this here. And then I've got for finisher and finishers. And then what I want to do is, all right. I can do append finishers to our loop to first append. So what this will do is it'll run through each one, it'll add it to this list, and then when I'm all done, let me print, and I call this first, and I don't want this to print until I'm all done, so let me get rid of the indent. So what I'm telling it to do now is I start with an empty list, and then I add each person one at a time, and then I print. Well, what am I going to print out? Rather than printing them, one after another, I'm going to print them. It should, let me just run it, print them as a list. And it does, Kai, Abe, Ada. So this is another way of creating a list. We're using a for loop instead. So this is kind of another way of doing it, where I might want to create a list by starting with an empty list and then running through this for and adding them one at a time to my empty list. Now, copying a list. Now, to copy a list, starting with something like finishers, then we might want to make a copy, and we want to copy the whole list. So the way to do it is to simply, let me go back to my Sublime. Here's my list. So now I want to make a copy of it. Let me get rid of this. So let me just say copy. And then what we do equals finishers. And then what we do is we start with the first index and put in a colon. So I want to copy the whole list. And, whoops. And then, there. Now let me print the copy. And so you can see what I've done here. Here's my copy now, is I've taken a list, I've made a copy of it, and now I've printed out the copy of it. So if for some reason you want to make a copy of a list, this is the proper way to do it. You simply say what the name of your new list is, then you look at your old list, and then you copy everything. You start at the initial position and end at the final position and copy everything in between into your new list. Now, if you do it a different way, it's not going to work. And that's here. So if I copy without using this approach, then if I modify the copied list, it'll also modify the original list as well. Now, for example, this is what if I decide to sort the copy. So suppose I did it in a different way. And by making a copy, let me go back here. Suppose I simply said, well, let me make an identical copy. Simply here, say the copy is finishers. I do it this way, I print copy, let me just run it and see what happens. Boom, look, my copy is the same as the original. But suppose I wanted to do something else and print copy. So what I could do now is, sorry.
Just do a sort.
Okay, so now copy dot sort. So let me do that.
Guys, just remember, that's not a great name, copy, by the way, but copy is a copy of the finishers list, so you don't get confused.
Yeah, so if you want copy fin.
That's fine.
Now copy fin here.
I just don't want them to get confused.
Copy fin. Just so. So now what I've done is I've created a list in this way. I've sorted the copy. So let me print copy fin, see what happens. Build, boom. So now look, they're now in alphabetical order. But what if I want to print my original list? Then what happens?
Well, what's going to happen? Ask him. Oh, too late.
Guess what? It has sorted the original list. Now, suppose I had done it the proper way, which was by using this colon here. So now I've created my copy of finishers by adding the colon. I then sort the copy, print the copy, and then print the original finishers. Now if I do, boom, look at this. I've got the sorted copy alphabetical here, which is in the copy of the fin, but my original list is unchanged. So if I had done it by a different method without using the colon here, then if I had done one thing to one of the copies, it would have done the same thing to the other copy. So if I were lazy and simply said copy equals finishers, something like this, well, I create a copy, but really what I'm only doing is pointing to the same memory, the same storage space. And whatever I do in that storage space affects the other thing. So if you're making a copy of a list, keep that in mind, that to do it properly, again, use your bracket and then your colon to create a true copy, one that you can then modify without modifying the original. Now, the last topic, and this is from chapter 4, we wanted to talk about is our tuples, something called tuple. Now, Dr. Conrad, did you want to talk about tuples, or do you want me to start talking?
You want to give it back to me?
So, yeah, so.
Go to participants.
I stopped okay, I stopped screen sharing, so now you should be able to start yours.
Okay, we'll see. I don't think so. I don't know, we're missing something here. No, you have to give it back to me. You have to go to participants.
Participants, just a second.
I should just come down there.
Just a second now. Participants, Sue Conrad, and then I'll ask you to start. Did that work?
I don't know. Okay, we'll see. Okay, I'm gonna share my screen. No, you have to give me you have to go to participants and you have to make me the host. We are really not, we need to practice this.
All right, I just made you the host.
Okay. All right. Oh, here it is, finally. All right, now we won't have that problem. Okay, so I think we can share my screen. All right, so I like to use Google Colab to be able to teach. So, and I'm gonna throw my Google Colab link out there on Canvas, okay? So all the things that we're talking about, you can go through pretty much the same. One thing that John didn't go through is that if you can see my Colab here, finishers, our favorite list of finishers, our copy, we already talked about that. But let's say we wanted to add something to the end of a list. Okay, we make a copy, so, and we want to add to it. Remember our method of append? So in this example, so you see where I'm looking right here, finishers. I made a copy of finishers, so I called it copy of finishers. And then I took copy of finishers and I appended Joe to this copy of finishers. And then I sorted the copy of finishers. So if you look here, I've got now Abe, Ada, Gus, oh, there's Joe, Kai, and Zoe, okay? And that, so, because then I printed it. And then let's say I want to remove somebody, okay? So here is my copy of finishers, and I use the method remove, and I'm going to remove Ada. And so if you look here, we've got Abe, no Ada anymore, Gus, Joe, Kai, and Zoe. All right? So understand that within, as we're building our Python knowledge, within this list now, I can add to it and I can subtract to it. So for example, let's say you want to make a list of items that you have on your pizza and you like some things and your brother likes something else, but they're similar. You make a copy of your list and then you add and subtract from that list to get the list that your brother wants. And that's going to be coming up in a few minutes in a little assignment for you. So a tuple, kind of a strange word, I think, is a list of elements that can't be changed. So you know, when it's, so here we would have something, for example, like I have a person, and maybe I'll go back to the PowerPoint for just a minute to make it seem more logical. Here's our PowerPoint, the example in the book. And the example of the book talks about something called dimensions. And it's, so here is a variable name that we call, that is a tuple, and we have two numbers associated with it, 800 and 600. And then what we can do is we can take this variable and we can do several things with it. But right now, the big thing we want to do with it is we want to be able to know how to just use it and print it. So we look at here this list of items that can't be changed. So I put together something, I called it person and equals, and then I put 3 variables here. So one variable is the person's name, one was date of birth, and one was eye color. Those were my 3 items that I'm going to have about this particular element called person, okay? And I'm going to print, so if I want to, I can print each item separately. So if I want to print the first element within this particular tuple, I would just say print, my tuple's name is person, index 0, and it prints Joe's name. If I want to print the second item, which is his date of birth, I just say print my tuple person, index number 1, which is 1996. And you can see the same as the third. Now, here's where it is a little tricky, all right? So let's say I want to print something that makes more sense to me about my person. So here, there are several different ways we can do it. My favorite way is to create an F statement, but some people want to put a strings in here. So there's 2 ways we can do this. So the first is we say print, which is nothing new. I'm not going to use my cursor anymore. Print, and then we have the F statement, which is the F for formatting, right? This is nothing new within our parens. And then we start with my quote. My name is, and now here we come to our tuple, and our tuple, and within that we have the curly Q brackets of our tuple and the index number I want. My name is, and here's my name. And then I have another, just a piece of text, born, and I put my next tuple item, which is person 1, you know, and then I just put another bit of text with eyes of within the curly Q, which is part of my formatted statement. Oop, 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 oop. I don't know what happened there. Person, and then I just kind of end my sentence and I finish my formatted statement because, you know, I have to do this, and then I close my print. Okay, so what happens here is we get, my name is Joe, born 1996 with eyes of green. And that's using our formatted F statement, okay? Another way you could do this is by putting the string within your print statement. So, you know, this is a text, so it starts out with a quote, of course, my name is, and then we have to do this comma to be able to tell it that, oh, we're going to have a string here, and the string is going to be our first item, person 0. And then we're going to add another piece of, we have to put quotes around our text here, and notice we have to put even our spacing. So a quote, a space before and a space after, and then we put the string, add the string person 1 to be able to bring in the second item of our tuple. And then once again, we have to do the exact same thing with the quote and the text again, and then we would bring in the string, and it should say person 2, just like that. And we should be able to, if I make it smaller.
Or scroll, use the scroll bar.
Yeah, I don't see it
Scroll over.
really.
What was just there, move your cursor up. Move it up. Your cursor right underneath that line
Okay,
there.
yeah, there we go. All right, so there, and then we just have the other string. This is our tuple again. And if you hold it up and it even tells you it's going to be tuple person and the item the second index, which is really going to be the green, our third item. And then we have to put the quotes around the period, and then we finish our print. To me, whatever way you're comfortable with, the point is that you have to identify the string in your print statement if you're not going to create a formatted statement like above. All right. So what do we need to remember about tuple? Tuple is a collection of items that don't change. And you access them by putting the name of your tuple, in this case it was person, and then the element number itself. So these were 3 elements: Joe 1996 green, which represents values, and that is how you would then access those items.
And it's important to keep in mind that the items cannot change. So you can't do things like sort that list, sort a tuple alphabetically. You can't address, and say, well, let me go in and change the year. That is person 1 from 1996 to 1997, if that's an error. We can't change them. It's immutable. All you can do is overwrite the entire tuple by replacing all 3 elements to change it. And it's a way of keeping something immutable. And it's also a way of ordering things. For instance, if you're collecting something and you want the first item to be a name, the name of the person, and the second, the year they were born, then you would use a tuple. And because you don't want to accidentally put first the year they were born and then the name, you want to keep this ordered list. So the best way to think of a tuple is as an ordered list, where there's a certain order to it, where the first element stands for one thing, the second for something else, and the third for something else. So if you were to create something like name, address, phone number as a triple, first is the name, second the address, third is the phone number, then you would use something like a tuple. And so if you look at anybody's tuple, well, the third element's should be a phone number.
So let's just quickly, I wanted to do one quick exercise before we leave. And if you have to leave, great. If not, please stay and let's do this exercise because it kind of brings everything together. So the first thing I want is we want to create a list of animals. So I could create this with you, but I want you to actually go in and code this. Create a list of animals. So how's it going to start? You're going to start it with, let's call it animals. So animals equals square bracket and create some animals. So if we look at my,
I have a quick question.
yes.
Is declaring tuples like declaring a list? You just use parentheses?
Yes, instead of brackets.
Okay, thank you.
I have a question.
Is there anybody else that wants to ask a question?
I have a question.
Yes.
So tuples can't be changed, but would there be a reason or any circumstance where you don't want those kind of values changed? Or like, I guess what I'm asking is, at what point would you use a tuple rather than a list?
Yeah.
Okay,
well, as I was saying, you want an ordered list. You want the first element to be somebody's name, the second to be their address, the third to be their phone number. What if you were to do a sort on that? Then that's going to mess up the order. That you can't say, go to that tuple and say, well, the first element's going to be a name. It may be a phone number instead. If you were to modify it somehow by sorting it, by appending, by changing, something like that. So the reason you use a tuple is where you want them to be ordered. There's a significance to the order of them.
Yeah, right. So I think John's, I don't want to beat a dead horse to death, but it's really that this list has got items in a specific order that you don't want somebody to add something in the middle of it. You don't want somebody to sort it in a different direction. And you might see, like, if you ever go on a website and you're updating your address, it doesn't just let you update your address. It makes you look at everything, and then it updates everything at the same time, because it's not going to change. It wants everything to stay in the order that it was within the database that it's saving it. So a tuple is preserving that order that has been determined by the programmer for whatever reason.
Yes, and it's kind of getting ahead of the thing too, is that you might want to actually do a test where somebody gives you a tuple and you want to make sure the first element is actually a name and not a number. And so you might run a little test on your program just to make sure they've entered, if you've asked them, for a tuple with a name, that they've provided you with one and not a number instead of a name.
Okay, so is there, so what is this here? So is there, so did we get the list of the animals? Okay, so then the next thing you want to do is I want you to make a copy of that list animals. So how would you do that? So you can look at my screen and you can see I just create a new list, copy animals, and I say it equals, and now notice it's got the index. So what is this gonna, what is this telling us? When I have this spelled out like this, animals, square bracket, colon.
It's the whole list.
The entire list is being copied, exactly. Okay, so if I print it, so if we go to my print, sure enough, here's my original list. Here is my next copy of the list. Okay, all right. So now the next thing I want you to do is I want you to add something to the copied list. So you can look at my code here and you see, well, here's my copy list, the name of my copied list, and I just append, and I'm going to append a human to this animals list. I could append a toad, I could append anything. Okay, so append. An append is a method, right? We learned this, so we just added it, and append is going to add it at the end. So if we go to my, I think I sort it, but if I was to just print, if I could spell, print, copy, animals. If I print copy animals, where is that human going to end up? Where should it end up at least?
At the end.
At the end, because it's an append. But then if I sort it, so here I say, okay, copy, animals, sort, okay, so now it moves it. All right. Now I want to point out one thing here. I capitalized the word dog up here in my animals. So when I capitalized it then, and I do the sort, the capital D will take precedent, and it'll be the first item in the sort. If I go back to my regular lowercase dog, you'll see then it goes back to in alphabetical order. So a lot of times when you'll be looking at lists, when you'll be actually working with data, you'll want to and the data might have mixed case letters and you're trying to do a sort, the first thing you'll do is you'll want to first read that piece of data and then make it a lowercase before you would then do the sort, so that you're always working with everything in the same case. Because as you can see, upper and lower case makes a difference. Okay, and let's say now I want to remove something from my list. Okay, appending is adding it, removing it is, like it says, remove it. So I want to remove snakes. So I, just say, here's a method, remove snake. I print my list, and lo and behold, we have, the list without snakes. So today we talked about a lot of things, actually. So we talked about tuples. We talked about lists, making a list, adding to a list, deleting a list, minimize using numbers for the statistics. We talked about then that indexing when we're copying, so we understand clearly how we copy and how we copy specific items and slicing. So this actually concludes everything with chapter 4. So we're about a day behind, but we'll just continue working on things. Your homework from chapter 4 is due I think it's due before like Wednesday. All right. So your homework for 4 is due. Chapter 5, we'll get through most of chapter 5 on Thursday. I will be in class on Thursday at school. I should be able to walk much better by then. So I'll be there on Thursday. So people, will there be anybody who's going to come on Thursday? I'll send out a
I'll definitely
message.
come.
Pardon? No, you don't have to. No. I'll send out a message, because if nobody is going to come, it's silly for me to go if nobody's there. So I'll send out a message, and if nobody says they're going to come, then we'll just continue to progress like this. If not, then I'll be there on Thursday. Okay. So get your homework done from chapter 4. And like I say, I'm very pleased with how well you folks are doing as we keep moving forward, because we hope to finish chapter 17 before the end of the semester.
Let me just add something. We've
Okay.
dropped exercise 4.4 from the homework. And the reason is 4.4 wants you to print from 1 to a million.
Yes.
And your collab would be awfully long if you were to do that. But the whole point of it, but it's something that you can try on your own, printing from 1 to a million. But the reason that it's put in there is that sometimes you will get in one of these loops that just keep going on and on and on. You can even get caught in an endless loop that won't stop. And so the reason they put it in there was to say, well, what if we get into one of these loops that's just going on and on, or it's printing too much? Then there's a way to escape, and that's by hitting Control-C at the same time. So it's to teach you how to escape from a loop if for some reason it's going on too long, or you make a mistake. For instance, printing to a screen is really no big deal, but what if we were printing, each one of these was a page? And we don't want it printing a million page. We want to be able to escape from this for loop. And so the way to escape from the for loop is by hitting Control-C. So that's something to practice on your own, but please don't do it, because I don't want to have to read a million lines of printout in your homework. All
right. I think we've covered a lot for today. We'll be doing chapter 5 on Thursday. All right. If you have any questions, stay, and we'll be here for office hours. If not, then I'll see you on Thursday.
So yeah, if anybody has any questions,
you.
just stay on.
Bye.
Thank you. Bye.
Bye. Thank you.